Sorry that last bit was rushed. I was just trying to beat the timer. But a word about the show. Show that. This right here. That's good news. If you see that on your exam, then that's good because you're given the answer. So all you have to do is say, okay, where did this M come from? I don't know. Where did that V come from? V and R? This situation, V and R, it's probably centripetal acceleration. Q and B, I know that's the force on a charge, QVB. So let's start with the force on a charge. And then F equals F. You're probably going to need to use F equals F. Electrostatic force equals magnetic force. Electrostatic force equals gravitational force. Whatever. F always equals F. So you can set whatever those are equal to. Just one more example. So what I just said, the electrostatic force equals magnetic force. Not for this problem, but just in general. So this equals KQQ over R squared. And this equals QVB. You can set those equal to each other. That's absolutely allowed. F equals F. That's what I mean when I say that. All right, let's see what else we got. Tendency of a moving charge to follow a curved trajectory in a magnetic field is called a mass spectrometer. If an unknown element is ionized and accelerated by an applied voltage in the chamber, then it's going to strike a phosphorescent screen and then it's going to flash. By measuring X, we can determine the mass of the ion, hence the unknown element. So, another use here. So, we introduce this ion into the electric field. So, it's a flowing charge. It gets deflected because the force in this instance is going to be pointed perpendicular to the velocity. So, the acceleration is perpendicular, so we're dealing with circular motion. If the particle goes way out here, it's a heavy one. If the particle is closer to this end, then it's going to be a lighter particle. Show that. Pause the video. Try that. You're doing what we just talked about. Try it. I'll wait here. All right. From the previous slide, remember we just solved for R equals mv over qb. So m equals rqb over v. From the picture we see, all right, let's get caught up here. From the picture we see that R equals half of x. So the radius is half of x. You see that? Here's x all the way here. R is half of x. So we get m equals r qb over v equals x qb divided by 2. All right, a couple multiple choice and we'll be on our way. Let's see, we've got this situation going on. A piece of aluminum foil is held between two pieces of strong magnet as shown. When a current passes through the foil in the direction shown, which way will the foil be deflected? Right hand rule, right? Force is going to be up, vertically upwards. Hopefully you got that one. Let's try this. All right, we got two parallel wires with the given currents in the given directions. The force on wire 2 is due to the current in wire 1 is F. Find the force in wire 1 due to the current in wire 2 in terms of F. Pause, try it out. Newton's third law, right? Object A exerts a force on object B exerts a force on object A in equal and opposite direction. The force on wire 1 and the force on wire 2 are action-reaction pairs. But action-reaction pairs have equal magnitude and opposite direction. So wire 1 feels the same exact force, F. Boom. See? That's it. That's all I got for you. Go do some practice problems, please. Ask questions as they come.